Welcome to this course on Introduction to the Python Programming and its Application.
In this video, we will going to see how to draw the confusion matrix for a given data.
So we have got a confusion matrix which is being used to tell you performance of the data with respect to the actual value and the predicted value. Okay, so let me explain you that what actually the confusion matrix means. As the name suggests, confusion, okay, it is been used for to give when the machine has confused to learn about or to predict the correct value. Okay, so it is a confusion matrix, and the matrix means we are talking with respect to the row and columns. Okay, so when we are talking about the matrix, that means if we take the 2 by 2 matrix, okay, so we have the two rows and two columns. So in general, if we talk about with respect to the graph, we say that, okay, what are my actual values? So here we write the actual values. And here we write what are my predicted values. Now, when we are saying actual values, we can have both actual value. Actual value can be positive or the actual value can be negative. Okay, so we write here positive for the actual value and negative for the actual value. Similarly, when we are talking with respect to the predicted values, again, we can have the positive value and we can have a negative value. So now if you see and compare this graph, if actual value was positive, okay, and the predicted value is also positive, okay, so here we write it as a true positive, that is a TP. Okay, and when we are saying, okay, the actual value was negative and predicted value was also negative, so here we write a true negative. Okay, so this is the diagonally, if we you can see this diagonally is the true values. Okay, so whenever we are talking with respect to this, these diagonals which we are getting is the true values. Now another case is that we have got a actual value was negative, but my predicted value is saying that no, it is not a negative, it is a positive. Okay, so I'm saying that my predicted value is saying it as a positive, but in actual it was negative. So what we will say here, we write this p here, that okay, it is saying that it is a predictive value is positive, but actually it was false. It was not a positive value. So I will write here FP because my actual value was negative. So it has given me a false result. So I'm writing here false positive. In another case, if you see that, okay, my actual value is positive. Okay. And again, my predicted value is negative. Okay. So what it has done, it has predicted it as a negative. Okay. But actually what it was positive. So what it has done, it has predicted as a negative, and again this negative is the false negative. So here we are writing a false negative. Okay, so these values, if you see here, this diagonal which we are creating, we can say false value. So we have the formula to calculate the accuracy. So we are calculating the accuracy based on the true positive plus true negative divided by true positive, true negative plus false positive plus false negative. Okay, that means this is the total samples which we have got. Okay, so it will give your accuracy in percentage. So if we are having the three classes, so this is the example of a two class. Okay, if we take an example of a three class, so we will be having a 3 by 3 matrix. So this will be my class 0, class 1, class 2. Okay, so again it will be my class 0, class 1, class 2, and here what we are saying that okay, this is my actual value and these are my predicted values. Okay, so whatever the things which we will be getting in the diagonal, my these are my true values, and apart from here, whatever we are getting here, 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 here will be my false values. Because we are going with the iris dataset, and in the iris dataset we have seen that when we have created a setup, we have used it has given the class as a 0, 1 and 2. So we will be creating a confusion matrix here first. Again we have to write a command from PyCaret dot classification import plot model. Okay, let me run this first. And then what I have to do, I have to plot the confusion matrix first. So I will be using a plot underscore model. I will going to plot the confusion matrix of a tuned LDA. So I will be writing tuned underscore LDA where we were getting a good accuracy, and the plot which I want is the confusion matrix. Plot equal to confusion underscore matrix. So let me run this first. So this is giving me a accuracy that okay, I was having total number of sample as 10, 11, 11. So you can see that 32 samples I was having. This is how you can plot the confusion matrix.